Okay, let's move on to Module 23, Lesson 2 to work with the volume of cones. We're going to go ahead and skip the Explore activity again and just move on to page 724 so that we can put into use what you saw in the video today in the introductory lesson on your PowerPoint. So you should have seen that there's a direct connection between the volume of a cone and the volume of a cylinder. To find the volume of a cone using a formula, we're going to use the radius of the base, and we're going to multiply to find the volume of a cone by doing 1/3 times the area of the base times the height. Okay? Or the volume is the base area times height divided by 3. However you want to look at it. Okay? So in this case, if we keep going, we were able to notice that 3 cones in the video fit into 1 cylinder, which is where the 1/3 actually comes from. So we're going to use this volume equation to help us through these example problems, and then we're going to do some on our own. I'm going to adjust the camera a little bit just to be closer to the page so that you guys can see better. Okay, there we go. So to find the volume of each cone, we're going to go ahead and multiply 1/3 times the area of the base, which is a circle. So the area of the base is pi r squared. And we're going to plug in. We have 1/3 times pi, 3.14, times 2, the radius squared, times 8. Now make sure that when we're working with exponents that we're not using 2 times, well, in this case it would work, but if I had the exponent of 3 squared, we wouldn't do 3 times 2. This actually means 3 times 3 times 3. Some of you were making that mistake on your exit slips. So 3 squared, in this case as an example, we're going to move back to the problem. 1/3 times 3.14 times 2 squared, which is 2 times 2, or 4, times 8. And then we would pull out our calculator and actually do that math. I like to think of it as a division problem, so I would do 3.14 times 4 times 8, all of it divided by 3, instead of times 1/3. But you can go either way. So our answer would be approximately 33.5 inches cubed. Looking at this cone for part B, here it gives us a diameter. I don't want to use my diameter because that's not part of my equation for the area of the base of a circle. I want the radius. So since the diameter is 8, the radius is going to be 8 divided by 2, which is 4. Okay? Because the radius is half of the diameter. So once I start plugging back into the equation, volume equals 1/3 times pi r squared times height, I would have 1/3 times 3.14 for pi times 4 squared, which is 16, times 9. And if I plug that into my calculator, I personally do 3.14 times 16 times 9 first, and I divide all of that by 3 instead of multiplying times 1/3. But you can freely multiply times 1/3 if you would like. And I would get approximately 150.7 feet cubed. Okay, so that equation must stay ingrained in our minds because we're going to use it as we move towards these problems on page 725. So I'll rewrite the equation for myself because I like rewriting things. It helps them go into my memory a little bit faster and stronger. 1/3 times pi r squared times the height. Especially with all of these equations, it's nice to kind of be repetitive about using them and writing them down so that they can become ingrained and easier for you to think of in the moment. So it asks us to find the volume of each cone, round our answer to the nearest tenth, and use 3.14 for pi. Go ahead and pause the video if you feel confident and would like to do numbers 4 and 5 on your own and then come back to see the answer. However, if you don't feel confident and you'd like to see one, stay. So I'm going to start working on number 4. You should already have noticed that there was a problem here in our base. We don't want to work with the diameter. It's pointing at the entire line. We want the radius. So the radius is going to be 15 centimeters divided by 2, which is 7.5. And I'm going to get my calculator ready because obviously there are a couple of decimals here that we're working with. So my calculator, I'm going to use it to find and plug into the equation 1/3 times 3.14 times 7.5 squared times my height of 16. Quite large numbers. So let's start with 7.5 squared first. In that case, I'll do 7.5 times 7.5, which is 56.25. And I'm going to keep that decimal. So 3.14 times 56.25 times 16. And I'm going to do all of that divided by 3. Okay? So to get the most accurate answer, keep these decimals that you get from the problem itself and then actually use the rounding method in the end. So I'll start with my multiplication. 3.14 times 56.25 times 16, and I get 2,826. And I'm going to use all of that times 1/3 or divided by 3 to get 942 centimeters, and its volume, so cubed. Hopefully if you did that problem on your own, that is what you got. Let's move on to number 5. You should be telling yourself, well, it has the radius, so there's no extra work for me to do to find the radius. And I'll start plugging into my equation. Volume equals 1/3 times pi, 3.14, times my radius squared, 2 squared, times my height of 3. I can work through this part, so 3.14 times 2 squared is 4, times 3. All of that divided by 3 or multiplied times 1/3. So I'll pull out my calculator and I will work 3.14 times 4. Whoops, that fell. 1 second. Okay, better. Times 4 times 3 is 37.68. And I'm going to divide all of that by 3 to get 12.56, but I want to round to the nearest tenth, so I'm going to go ahead and round that to 12, round up 12.6 feet cubed, because we're working with volume, right? Let me just adjust that a little bit. Okay. So let's keep working then. Now that we can find this, we're going to go ahead and put it into practice by actually finding it in context. So for her geography project, Karen built a clay model of a volcano in the shape of a cone. Her model has a diameter of 12 inches and a height of 8 inches. So I already know that the 12 inches diameter is important and the 8 inches is important, because for my equation for volume of a cone, 1/3 times 3.14 times radius squared times height, I know I need a height, which it's given me, and a radius, which it's semi-given me. So it's asking me to round to the nearest tenth to find the volume of her clay model of a volcano. To find this, I need to first find my radius. It's giving me a diameter of 12 inches, so my radius is going to be 12 divided by 2, or 6, right? So I'm able to now start plugging into my equation. 1/3 times 3.14 times 6 squared times 8. So I have 6 squared being 36, and if I solve all of this and divide by 3 if you'd like, I get 301.44, But I'm rounding to the nearest tenth, so I want to use 301.4 inches cubed. Let's us put that into context while we work on number 6. If you feel confident working on number 6 on your own, feel free. Pause the video and come back. Otherwise, stay with. So for number 6, it says the cone of a volcano Paricutin in Mexico had a height of 410 meters and a diameter of 424 meters. Approximately, what is the volume of the cone? Well, what's important here is the diameter of 424 meters and the height of 410. And when we're working with volume of cone, cylinder, sphere, even if it's not given, we assume that pi is 3.14, okay? And we typically assume that we want to round to our nearest tenth. So let's go ahead and start working. I'm going to pull out my binder paper because I need some space here. I'm going to rewrite the volume equation. Volume equals 1/3 times pi r squared times the height. So I'll plug in what I know. I know 1/3 stays intact times 3.14 times my radius, but it's not giving me a radius, it's giving me a diameter of 424. So in order to find my radius, I'm going to divide 424 by 2 to get 212 squared times my height of 410 meters. This is going to take quite a few numbers, so I'm going to use my calculator instead of multiplying in the triple digits. And I'll go ahead and multiply first 212 squared. So 212 times 212. And I get 44,944. So I'll bring down everything else. 1/3 times 3.14 times 44,944 times 410. You really want to make sure you stay organized as you're doing these equations because it's easy to get lost in your own work like some of you have seen recently. Now I'll start multiplying here because in the end I am going to choose to divide by 3 as opposed to multiply by 1/3. So I will do 3.14 times 44,944 times 410. And I get 57,860,905.6. But I'm going to divide all of that by 3 to find my volume. So my answer divided by 3, and I get a decimal that I can round to the nearest tenth. In this case, it's 0.533333, so I'm just going to round to 0.5. So my answer is going to be 19,286,968.5. So I'll write that in here in our assignment. My volume is 19,286,968.5, and I need my units, meters cubed. Hopefully if you're back to us, that's what you got. It's quite a bit of work for these volume problems, but it's definitely worth it to use, and it is something you will use in daily life or in life as you move forward. Definitely in geometry as you move forward in your accelerated track. So for your homework 23.2, I want you to do the odd problems, 9, 11, 13, 15, 17, okay? And then if you feel like doing the evens or even some of the hot questions, feel free. The homework answer key is posted for you, and don't forget to take your exit slip as well. All right, good luck, you guys.